Hi guys, today we're gonna do actually mechanical drives, and there are a notice number of them. We've got the belt drives, we've got the chain drives, we've got the gear drives, we've got the tooth type drives, and so on. So today let's deal with belt drives. Belt drives. What is the function of the belt drives? Let me illustrate that by means of a sketch. If you've got a pulley, two pulleys rather, diameters that, and you've got a belt there. These are two pulleys combined together by a belt drive. This is a belt. The whole process is called a belt drive. Now, the tight side, if you can see, this side is more tighter, is the tension on the tight side. And then this one, you can see it's not as straight as this one. We call this one is the slack side, and is T2. These are called tensions. And then this angle here, this angle, there where the belt enters, let me do it, where the belt enters and where it exits, this angle here, there, which is this angle, we call it an angle of contact. And this is arc of contact. That angle is the angle of contact. The speed at which this belt runs is the velocity. So normally the pulleys here, because of its rotation, its revolution. The speed is in n. This is revolution per second or revolution per minute. If it's given in minutes, you divide by 60 to convert it to second, and so on. Now, the T1 over T2, this thing is called the ratio, and the power transferred by this belt from the driver pulley to the driven pulley is called the power transferred, is equal to the effective force multiplied by velocity. Now, this effective force, it is the tension on the tight side minus the tension on the slack side multiplied by velocity. This is the power. But one would argue saying, but I know power is work over time. Look this. Power is equal to work over time. But what is work? Work is equal to force by distance over time. Is equal to, this force is this one. From the Newton's second laws of motion, S over T is the velocity multiplied by V. And this F stands for the effective force, and is that one. That's basically where that formula comes from. From first principle, you can still derive that power, that power. And this is the transferred power. The power transferred. If you've got a motor here, and then this motor is coupled to the pulley shaft by means of a coupling. It can be a mechanical coupling, can be fluid coupling. It depends on the design or on the requirements of what an engineer wants. Let's say this is a motor, it's rated and so on. So yeah, you've got power, you've got the velocity at which that belt is driven, and then of course you've got the angle of contact. So basically that's the case. Now let's go back to the beginning. What is a belt drive? You've got a motor here, the pulley is attached to the shaft of the motor by means of a coupling. Now, this motor gives power to that pulley. That pulley the belt attached to that pulley transferred that power to that to the pulley where there is no motor. Now it means a belt drives, they transmit rotary motion, rotary from rotation, rotary motion and power, because this belt transfer power. It's rotary motion and power from one pulley to the other. If this thing rotates, there is a belt attached to it which is also connected to that belt. If it rotates, it will also rotate, but they rotate at a different speed, and you'll see at the later stage why. So basically this is the case. Now in practice it happens that this belt slips. It is actually one of the disadvantages of a flat belt. Now if it slips, there are only two ways to improve that slip. One, you proper tension this belt. Let me put it by proper tensioning of the belt. That's number one. Two, you increase this arc here. If this belt was moving out here, you can bring it here so that it can be tight on the pulley. Increase the arc of contact. The arc of contact between the belt and the pulleys. And then of course we have said the power is the effective force multiplied by velocity. And then to calculate the velocity of this belt is pi d n divide by 60. Divide by 60 if this is given in revolution per minute. If it is given in revolution per second, you don't need that 60. So for now, let's assume out of 100, 2/3 of the time it will be in revs per minute. So let's put 60 there. That's basically the case. Now, where can you use this flat belt? These are actually flat belts. Well, in the plants or industrial plants, it can be used for drilling machines, number one. In my car, I was standing with one of the guy who said, hey, we are only studying, we don't have experience. Yesterday I was standing with him on my car there, and he was shocked that we completed this mechanical drive within an hour, and he could understand actually what's going on. So they can be used for drilling machines, number one. Two, in a car, in the fans or water pumps of motor vehicles. That's number one. Two, it can also be used again in the industrial plants of mines as water pumps for boreholes. In farming, for instance, or where the tractors normally pull farming implements, as they cut the lawns, major lawns there, you'll see there's a belt drive there as well. That's basically where they can be used. And then the advantage of this is that slip actually can prevent a very, very serious damage. Because let's say, for instance, your hand get into that. Instead of it moving, it will rather slip. And then you will still get injured, but unlike maybe your hands being cut and so on. But in that way, they prevent a serious injury. Secondly, with regard to the disadvantages, I will say we always change belts or one other thing with regard to advantages is that these belts are relatively cheap. They are cheap, you know, it's less than 200 rand if you buy them for your car and stuff. But they slip, they slip too much. That is the main disadvantage. They slip, number one. And then one other thing, they are, what can I say with regard to sleep again? They've got short life. They've got short life because sometimes you may find that they have got you have to change them after 120,000 kilometers or so to be on the safe side. So for that reason, it's a short life and so on. And then still on the belt drives, you've got the tooth type belt. Normally on your car, it is just a slag. They call it a timing belt. It is used for driving camshaft on the motors, and you know that they are the very high speed power tool. And the reason why they are light, that the advantage is that they've got a positive grip and so on. So basically, this is what you should know regarding the belt drives. I haven't talked of chain drives, which will be used at a later stage to overcome the disadvantage of flat belts and so on. Let's do one problem or two if maybe time allow. Well, you know, unfortunately I don't have time here. Let's do one problem or two because I've been given 30 minutes on this belt drives. I will still explain a lot of stuff as we continue with regard to the belt drives. So it's my book, guys. This is actually the N2 book. It's for students normally who normally ask me. I don't just choose chapters. People call, people comment and say, please attend to this chapter, we've got a problem, or hey, we are corresponding, we don't have time, we study part-time and so on, we are working at the mines, can you please approach this? That's why I said please drop your own question or see how you can find me. If you don't want to drop a comment, find other means of finding me. But if you are on the channel, remember to comment, subscribe, guys, and share so that we can grow this channel and so on. Let's take a problem, a serious problem that can solve the issue of belt drives. Then you know you are covered for belt drives, and at a later stage we'll deal with gear drives and chain drives. They say let's take this one, and we're gonna take three. This actually looks easy. They say a pulley is driven. Okay, let's say basically it's this one and this one. Hey. For argument's sake, guys, this is actually the case. Right. They say a pulley is driven at N is equal to 850 revs per minute by a flat belt moving at a speed. Let's say the speed, the velocity, the linear velocity of 12 meters per second. Now, the tension in the tight side, that side, T1, this one, T1 is equal to 360 Newton. And the tension ratio, the ratio between the other side of the belt, the tight side and the slack side, ratio, which is T1 over T2. This is a ratio, guys. And it's equal to what? It's equal to 8 is to 8 is to 3. Now calculate the tension in the slack side. Calculate the tension in the slack side. Okay, meaning T2 here is equals to question mark. But now look, we've got this one. We've got this one, and ratio is 8/3. 8:3, guys, is the same as 8/3. Is divide. And then this is given as 360 over T2. You want the slack side. Tension in the slack side is equals to 8/3. Let's cross multiply and find T2, which is the tension on the slack side. Therefore, T2 will be 360 multiplied by 3 divided by 8. And it's equals to what? It's equals to, can I get a calculator there? Okay, thanks. 360 multiplied by 3 divided by 8, and it's equals to 135 Newton. 135 Newton. The tension on the slack side is 135 Newton. And then one other thing is what? The effective force of the belt. Straightforward. The effective force of the belt. Remember, guys, we said the effective force is equal to the tension on the tight side minus the tension on the slack side. And it's equal to what? You are given 360 there minus, you just calculated 135. 135. And this is equals to, this one is 2, and then 60, that, this one is 25 Newton. It's equals to 25 Newton. Let me just, 360 minus 135, 225 Newton. That's correct. Now, this is the effective force. The effective force. Now, the power transferred in kilowatts. The power transferred by this belt from there to the other pulley, from that pulley to other, from the pulley that has a motor to the one without a motor. That's what is needed. And we know that power is equal to the effective force multiplied by velocity. And you just calculated 225 multiplied by, this was a very easy question, actually just for practice, because you are, everything is given there. You are given 12, and which is equal to what? 225 multiplied by 12, 2700 is 2700 watts. But they said the answer must be in kilowatts. This is 1, 2, 3. Guys, I hope you know that the word kilowatt means 1,000. It means your comma move 3 zeros. It's 1,000 that have 3 zeros. So it's 1, 2, 3, and it's 2,7 kilowatts. Kilowatts. And then what? The diameter of the pulley. The diameter of the pulley. The diameter of the pulley. This is the pulley, the diameter. The diameter, a line that divides that pulley into 2 halves. You are given what? You are given this, meaning velocity is equal to pi d n over 60. Why 60? Because your rotational speed is given in minutes. If it was in rests per second, this 60 wouldn't have been there. So it's 60, which is equal to 12 multiplied by 60. Why 12 is given? Is the linear speed at which that belt is moving. We cross multiply, we divide by pi, multiply by 850. And it's equal to what? It's equal to the diameter. Now, what is 12 multiplied by 60? is 720 divided by open brackets second function pi multiply by 850 closing brackets answer. This is 0,2696 meters, but remember normally we use millimeters. We multiply by 1000, which is diameter is equal to 269,627. The whole number there will be 270 millimeters. So basically that's what is needed there. But they can give you, this question is amount to 10 marks. It looks easy, this one, because most of the things were given. Most of the things were given. Let's take another one before I can, in closing. I hope I still got time there. I still got time. I'm giving 30 minutes on this video, guys. So let's take another one. And it says what? It says a pulley with an effective diameter of 250 millimeter is driven by means of a pulley fixed to the shaft of an electric motor. What does that mean? It means, it can only mean one thing. It means we've got a pulley fixed to an electric motor. It means each shaft is connected to the motor shaft by means of a coupling. This motor gives power to that, and then this transfer power to that one. We use a belt to transfer power to. When this thing rotates, this belt moves and that thing will automatically rotate. That's what is meant by rotary motion. Right. If the speed of the driven pulley, the one that is driven, this one, because it is attached to the motor and it gets power from there, it is the driver. The driven is this one. N is equals to 500 revs per minute. And the tension in the two sides of the belt is, it's 170. Yes. T1 is equal to 170, and then this one is equal to 18 Newton. Units are very, very important, guys. Calculate the power transferred. Right, we've got that. Let's calculate the velocity there. Why? Because most information is there. Here we've got nothing. So velocity is equal to pi d n over 60, which is pi multiplied by, what is the diameter of this? It is 0.25 multiplied by 500 divided by 60, and it's equals to second function pi multiplied by 0.25 multiplied by 500 is equals to that divided by 60. Is equals to 6,5. Is equals to 6,545 meters per second. This is the linear velocity. It is the speed at which this belt moves as the pulleys rotate. Right. Now we've got the velocity. We've got the tensions on both sides. We can calculate the transferred power, the power transferred by this belt. Power is equal to T1 minus T2 multiplied by V, which is the velocity. And then this is 170 minus 18 multiplied by 6,545. And then 170 minus 18 is equals to 152 multiplied by 6,545. It's 994,84 watts. This is the power transferred by this motor here. But there is a catch. Let me just tell you one thing. If you've got the supply here, the galley box, it will supply that motor with a 3-phase wires. The 3-phase system. It supply an induction motor. This is the input to the motor. And then we've got an output there. This output here, it is the input to the drive there. That's very, very crucial. Just remember that, guys. The output power of the motor, if the efficiency of the belt drive is 88%. There we go, already. There we go, already. You are given the efficiency of the belt. The efficiency of this belt. Look, efficiency is equal to the output power of the belt divided by the input power of the input power of the belt. This is very crucial, guys. There's always a catch. This input, it is the output there. The input of the motor is this one. But the motor gets hot. If you touch the motor like this, it's hot. Why? It's because it is an indication that there are losses. That is why the output will never be equal to the input. But this output to the motor, it is equal to the input to the drive. Now, we've got 0,88 of the belt is equal to the transferred power. There is equal to what? 994,84 divided by P in. The reason why it's like this, guys, remember there was 100 here. So we have divided by 100 and then we are left with 0,88. Therefore, P in is equal to, you just make P in subject of the formula. We have cross multiplied. There is 1 there. So it's equal to what? It's equal to 994,84 divided by 0.88. And it's equal to what? It's equal to 1130,5 watts. Kilowatts. No, watts rather. Sorry. Watts. What does this mean? This is the output to the motor. But on that output, only an amount of 994,84 is transferred by this belt when the efficiency of that belt is 88%. Basically, that's what those people are asking you. And then the effective diameter of the pulley on the motor if it rotates at 1,000 on the motor, this one, the effective V is equal to pi dn over 60. We want this one, the effective diameter, and we've got how much? This is 6,545 multiplied by 60 divided by pi multiply. If it rotates at 1,000, if it rotates at 1,000 revs per minute, therefore the diameter of the driver is equal to what? Is equal to 6,545 multiplied by 60 divide by open brackets, second function pi, multiply by 123,000 is equals to 0,125 meters. Multiply by 1,000 is 125 millimeters. The tension ratio, guys, you will finish this one, I don't have time anymore. Ratio is equals to T1 over T2. You've got this one, 170 divided by 18 is equals to what? 170 divided by 18 is equals to 9, okay? Is equals to 9,44:1. What does that mean? The pinion gear rotates 9,44 times, while that pulley's make one complete revolution. That's basically what that ratio says. And then it says the belt speed. We calculated the belt speed initially already, which is 6,54. I will see you in the next video. Please remember to subscribe and share, guys. Bye bye. I hope you have a wonderful time as you prepare.